Next up, we're going to look at our detection use cases. The first I want to cover off is RDP patching. Now, what we're going to cover is essentially a stealthy access or defense evasion technique where an adversary may patch the RDP DLL, and that's termserve.dll. By default, non-terminal server operating systems will only allow one concurrent RDP user session at a time. So what the patch does is it essentially removes that limitation. So I've seen adversaries use this for accessing like finance users and wanting to install keyloggers, but needing to access the box and not wanting to tip them off. I've also seen kind of sneaky admins just use it for software piracy. So it's a really interesting use case. And the reason why I'm using it in that it's one that we can detect in multiple angles. So it lets me cover off several different detection scopes. So you can see on the screen now our detection opportunities. So an example might be a disk search for the patched DLL, memory search, the patched DLL. We can also look for service DLL replacement, which is a little bit different than the patched DLL. In this case, we're looking for service DLL, maybe pointing in the incorrect place where they could have, say, some malware that would load, or maybe even a DLL forward from an unexpected DLL back to the legit DLL. We can also look at various telemetry-based kind of detections, and that's straight from the MITRE page. In this kind of lab, I'm not going to be covering telemetry because I think Velociraptor's main value is the forensic capabilities. Okay, so there's the link. If you follow that, it will take you to the landing page, or click on the notes, and I'll see you in the lab. Okay, so we're going to look at the patched RDP lab now. And I've got fairly detailed steps. But first of all, I want to show some of the patched RDP, what unpatched looks like. So one thing that is not in here is you might need to turn on remote desktop access for your machine. So here we're enabling remote desktop, and I've actually created two RDP kind of links, and we'll use those later. But first of all, I'll log in with my default user, and you can kind of see my user's been locked out, and now RDP, I'm logged in. So then in our instructions, we have to create a new user, and we do that by opening a new command prompt. We should still have this one open. That's not an admin, so we'll make sure we have an admin. And essentially, we're just adding a new user and adding it to the local administrators group so we can RDP in. Next, we want to RDP in with the second session that we have. So I'll see if I can bring that up. Move that down. And I'll run this account and admin user. And the password is password. And when we log in, you can see the message that we get. And obviously, hitting yes, our other user is knocked off. So we'll just hit next. We're logged on. And let's just open up a command prompt just to confirm. Run Q user. And you can see the original user YOLO has been disconnected while admin user is active. So in the instructions to apply the patch, we have a PowerShell command. And what this is doing is it's reaching out to Gist and installing a PowerShell script that I have. But we're going to run this script and it's going to apply it. So if we open up PowerShell and run as administrator, and what it does is it essentially backs up the terminal services DLL, and then it will overwrite a copy of it with the patch. So hit yes. When you are patching RDP, you need to stop the right services in the right order. So it does take a little bit of time while you wait for these to happen. Obviously, if you're accessing a box remotely via RDP, doing this, you'll probably lose connection. So you can see here that it's saying, hey, the patch isn't there, and then it's patching it and then showing the comparison at the end. And then it restarts the services. So to test that that's all working, now we run the same process that we ran previously. So here, we log in as YOLO. And we're logged in there. And I'll log in as admin user, password. When I hit continue, you can see there's no warning. Because we've got Q user up, when I hit enter, you can see there is 2 active sessions. So the patch is applied and it's actively bypassed the terminal services restriction. So the next stage of this lab is we're going to actually search for the patched termserve.dll. And what I'm trying to replicate here is kind of how I approach a detection of this type, in that what I do is I try to use existing built-in artifacts for ease of deployment. And in the example that I'm giving here, I'm using the VAT artifact again, and I'm searching for the patch DLL in memory. So what we need to do is create a new notebook and add a new cell. And this is showing the benefit of doing your development in Notebook, because it's very easy to call an artifact. It's very easy to just roll in a new Yarra rule or mess with these variables just to get an idea if something's working or not. So in this case, we have our Yarra rule with our hex of the patch that we want to detect. We're using the VAT artifact. We're targeting SVC host. We're targeting termserve.dll as the mapping name. And then we're applying our Yarra rule to those bytes. And that will go off, and see how fast that is because we're doing the targeting. But you can see things like process chain, and you'll have like services.exe here, and then init here as well. But it gives you a really good idea of how optimized this kind of scanning is. So we know that works. The next kind of thing we might be interested in looking at is finding it on disk. But before we do that, I'll just coming down here, you can see we've got some error notifications. These are normal. These are just permissions things. And down the bottom, the way this artifact works is it will upload the Yarra hit, and that populates the hit context view that we saw in the previous labs. So this is kind of normal, but this will give us an interesting result on the next hunt that I kind of wanted to show. So the next query we're going to run essentially the same rule, but this time targeting disk. So when we come back, I'm going to essentially run artifact Windows detection Yarra NTFS. I'm going to use the file name regex looking for termserve.dll. And when we hit go on that, it will go off and scan the MFT. Now, this is a really good use case for the file name search, and running a similar hunt. I've found cases of unexpected files in staging locations. I've found deleted files. It's a really nice capability when you have this kind of use case, opposed to Glob, where you might need to search for the whole disk or kind of know where you're looking. And when results come back in, you can see we have a hit, and this is in Windows temp. This is actually from the next stage of the lab, but we should see another hit pop up soon. And there is the main patch DLL in WinSXS. Cool. So same story as before. The hit context, if we were running the artifact in normal mode, we'd see the context here. But for the purpose of running a notebook and developing, because essentially what you do is you'll probably be running this a few times when you're kind of figuring out, what you want to run. You might run it once with the glob, yarra.glob. You might run it with Yarra NTFS and kind of compare how each works. But we'll move on to the next kind of part of the lab. And I've already ran this first bit, but what you need to do is essentially open up a PowerShell, and what we're doing is copying the termserve.dll to ctemp, and this is just for the demo, and then we're modifying the service DLL path to point to that new path. And this is just to test the detection. An adversary, of course, might do DLL replacement somewhere or use it for a persistence method, but we're just using it for this use case to test this particular service. So what we're going to do is then come back into our notebook, and you might take some time to dev this out. But say you would run this initially like this, right? And you'd figure out exactly kind of what you were looking at. And that should finish after a few seconds. And then typically for content dev, you could either use that or you could do something like add cell from this cell, just so you don't need to rerun the artifact. Then you could do something like where name equals, just to find the thing that you're interested in. So in this case, what was it, term serve or something. Just use a kind of generic type term, just so you've got lots of hits and you can kind of see, oh, I was able to guess pretty well. So then we can kind of say name equals term service, and name equals remote desktop service. And I like to use a couple of filters just to make sure. Add that in. Now, we didn't calculate the hash on this one, so let's do that again. So remember, question mark will give us the details. And then we want certificate info too, right? We know our regex now, so we can say display name regex equals we'll typing today. And this will run the same as last time, but we'll just calculate hashes and authenticode, right? At this point, you might be interested in, hey, what fields do I want? Maybe we just want the state, the display name, etc. And that's kind of what I'm trying to get across with these labs, right? Is you use this notebook because it's so easy to mess with data and figure out what fields you want to add. So from a content development perspective, it's super handy. I want the PID as well. Path name, service type. Hopefully you get the idea. You don't need me to go and type all this stuff out. Down the bottom, I should refresh this too. When we refresh that, you can see it's got our updated MD5 details and cert details. But the final query that I came up with was this one here. I'll just copy this in. And you can see we're calling the artifact. We're specifying remote desktop services as the regex. We're saying calculate hash and cert. And then we're adding this check at the bottom as well, looking for any DLLs that have an untrusted authenticode. And you can see the results there. So the final step here would be, we've got our 3 detection points. How would we put them together and kind of make an artifact of this stuff? Velociraptor has the concept of scopes. And if you look at my instructions, I've included kind of like a screenshot of some scopes there, right? And what I recommend is having a go at creating an artifact yourself that's like this. And this kind of method is what I use a lot of in terms of if I'm writing a detection artifact for a CVE or like an artifact that is covering a certain thing, like a patched RDP, I will write a few different collections in one. And that's what we're trying to do here. So I recommend stopping the video and going off and having a go at doing that yourself. Alternatively, I'm going to kind of show you the solution because I have added it to the artifact exchange. So you should have already done this step in the initial setup, but what we need to do is just hit this plus button for a new collection and then go to exchange, and we're looking at running the server artifact, import artifact exchange. And what this will do is it will go away and grab all of the content that is our user shared content on the Velociraptor artifact exchange. And when that's done, we can come to our search bar and type in exchange, and you'll see all the exchange artifacts. But what we're looking at is this one, exchange Windows detection term serve. And you can see here, I've just kind of made this nice by adding in a description, adding in references. I've added some parameters to make it easy, but it's exactly the same thing that we've worked on. And each section has its own source here. So this is the final step, really, of doing this kind of content dev, where you kind of loop it all together and then you create an artifact. So we'll come and we'll test this. Okay, so when we run this, you can see available parameters. The expected service DLL. We don't need to worry about resources because we'll run under 10 minutes. But I guess that's probably one of the things to mention with these combined artifacts is you might need to be a bit aware of the resource use. So for example, if you've got a lot of kind of combined queries, you might find it runs more than 10 minutes. And when you're running a combined query, the 10 minutes doesn't start again for each one. It's per collection. So what's running now as Exchange Windows Detection Term Server is the 10-minute interval. So you can see this has been about 40 seconds and we've got, I think, the VAD hit already. So it might take another 30 seconds or so. It really depends on things like how busy is the machine. I'm testing on a VM and the performance hasn't been great. So it can be a little bit longer or shorter depending on what else is happening on my host machine. Okay, now that's done, we can see results. And we've got a section for each result. This is what I was saying around the hit context details. You can see we've got the nice preview view here. This actually works by uploading, and you can see the section here is referenced, and that's the same view here. But if we come back to the results, you can drop down and see our NTFS. Yep. Now, we've actually got more than expected hits here because I used a generic regex in my initial rule. I'll show you if we go back to this and configure parameter. The file name here, there was no end. Sorry, no end and no start. So what that's meant is this is actually the Velociraptor data store. So I've actually detected the patch inside this hit that I've pulled back before. So in this case, it's just a bit of junk data, but in real life, you find you actually hit on some interesting use cases. So that's why I'm a little bit looser on this particular regex. But the files that we're interested in is this bottom one and this top one. And the others are in the Velociraptor data store, which is an interesting nuance, I think. So it's worth kind of seeing it. And finally, the services, and we've just got the default information. But one thing I've kind of changed here is I'm only outputting the service DLL details. So the name, the hash, and the authenticode and PE info as well. Right. I'll just make this a bit smaller so it's a bit easier to kind of see. One of the problems of doing demos is that it's always a smaller screen to get the formatting right. But you can see PE info, and this is just a patch term server DLL, so it's going to have all the same or PE information. It's just that hex patch has been changed, so authenticode is a little different as well. Cool, that's pretty much it for this use case. As I said, have a play and think of some other use cases that you can deploy like this. Like typically I'll deploy CVE stuff like this, where I'll have multiple detections for each kind of part. But I recommend having a play and giving me some feedback or having a go yourself with deploying this kind of stuff.